guys, it's Monday for our KAP lesson. This is our warm-up, so pause and play when you have your answers. Okay, how I do it with my classes is I say, when I'm adding with different signs, I think of them as teams, the positives versus the negatives. I want to first see who's winning. That's the positives because there's more, and how many they're winning by. They are winning by 9, so that is my answer. Okay, on this next one, it's subtraction, and it's a little weird. So you can solve it as this. If you have like $11 and you took away 70, you know you would be in debt, and you figure out by how much. But what I prefer to do is rewrite my equations into addition. If you remember, you keep and add the opposite. You keep the first number the same, and then you add the opposite. You add negative 70. And then you can do that teams thing. The negatives are winning this time, and how many are they winning by? 59. Okay, so my answer in that one is negative 59. Okay, again, addition of different signs. I have more positive, so my answer is going to be positive. But for this one, you definitely want to work it out because there's some regrouping. 6.0 and 2.6. Of course, line up those decimals. And this is where the mistake happens. If you did it in your head, there's regrouping. Okay, 4, bring down the decimal, 3. My answer is a positive 3.4. Okay, and then this is a little review from last week. Remember, when there's no sign, no operation, that means to multiply. So this is going to be a positive 20. Okay, now we're going to hop into notes. I would highly encourage printing them out. If not, you sort of have to pause and play as you go with copying into your ISN. Okay, so just before we hop into this, remember last week, let's review that we talked about multiplicative versus additive relationships. Okay, and it was just one or the other. At some point in this week, probably tomorrow, a little bit today, we are actually going to be combining those two. Okay, we're going to have relationships where they both multiply and add, or multiply and subtract and stuff like that. Okay, where it's still based off of the same things, but we're going to sort of call different things different names. We're going to show different ways to find it because it does get a little spicier. Okay, so the first thing, we sort of talked about multiplying relationships where you have like y equals ax. Okay, that number that you multiplied by is what we call the constant rate of change. That's just a different name that we use for it. Okay, so the constant rate of change is a ratio. Okay, it's a ratio. So the order is going to matter where you put things. Okay, what is the ratio? It is the ratio that represents the change in y to the change in x. Now, if you remember back when we did percent of change, I don't want to write that out, so I can use the triangle for change in y over to the change in x. Okay, it's literally showing, it's going to show that it's a steady and constant rate at which it's going. Okay, so in math, we use the letter M to represent our rate of change. But again, it's just like our multiplier. It's this number right here in our parent equation. Sorry, my mouse is acting weird. Okay, just that multiplier. So to find it again, it's the rate of the change in y over the change in x. It's that ratio of this to that. Okay, once I find that multiplier, I can put it in that parent function of y equals mx. Okay, so again, m is talking about that multiplier, and as I mentioned at the beginning, sometimes it will add. Okay, so let's call it mx plus a, or actually I'm going to change it to mx plus b because that's what you're going to see on the star chart, and I'll show you in a second. Okay, so again, the reason why it's a little bit more complicated is we might have a multiplying relationship or we have an adding, but in 7th grade we have both. This is some 7th grade skills we're working on. Big thing though, we're focusing on m being the multiplier, being the rate of change. Okay, again, to find that, we're going to practice now, find the change in y over the change in x. Okay, to do that, we're just going to look at this table first. The change in y, what is happening each time from one to the other. Okay, I see that it's adding 6, yep, adding 6. Over here, the change in x, they're adding 2, yep, staying the same. So already I'm thinking it's staying the same, it's steady, it's constant. Okay, let's actually find it. The change in y is this over here. It was adding 6 each time. The change in x was it was adding 2 each time. Of course, we want to simplify. That's the same as 3 over 1 all the way down to 3. My rate of change, I abbreviate, rate of change is 3. Okay, my multiplier is 3. M is 3. Okay, if I were to plug this into that parent equation, I'm replacing m with 3x. And we can see if we need to add anything. If I put in 2 times 3 is 6. I didn't need to add or subtract anything, and we won't for a few problems. Tomorrow we will start including that a lot more, where it's those 2 steps. Okay, let's look at another one. Okay, again, m. What is m? It is the change in y over the change in x. Change in y, what's happening each time? Oh, that one's weird. Okay, so that one's plus 1. That one's plus 7. And then that one's plus 9. Okay, so that's changing. So that's already giving me some heebie-jeebies. I don't know for sure if it's not constant, but I'm already on alert. Okay, that's plus 1. Okay, so this side is staying the same. Let's see if that changes anything. Okay, let's find the change in y over x. For that first one, 1 over 1 simplifies to 1. Okay, over here, the next one was 7 over 1. So I see that simplifies to 7. So I'm already like, that's not constant, it's not the same. And if I kept going, 9 over 1 simplifies to 9. This table, this whatever, is not constant. Okay, you can also see that looking from x to y. That's adding 4, then it changes that all up, adding something. This is not at all constant. It doesn't have a multiplier. That's staying the same. Okay, so I want you to try the next 2. Pause and then play when you're ready. Okay, again, m is the change in y over the change in x. They added 12. Added 12. Very good. So that change in y is 12. Going over to x's. That was adding 1 each time. That simplifies. Okay, let me go ahead and ask this. I'm going to sort of change things up from what's there. If I, okay, it was adding 1. I didn't write that in, sorry. If I put, let's say 7 and 84. Okay, let's find that change. Well, that one changed by 24. So again, I'm like, is this going to change things up? I don't know. Okay, going from 5 to 7, that was plus 2. Well, hold up. Wait. Okay, if I put the change in y over the change in x, the change in y over the change in x, that still sticks with it because that still simplifies down to 12. Okay, so I just want to emphasize, just because it's weird numbers, just because they're all different doesn't mean that they're not the same. But if one side is staying the same and one is changing, it's not. If both sides are changing, there's a chance that it could still be constant. Okay, so again, in both of these, the rate of change, m, was equal to 12. 12x, it was my multiplier. Okay, over here, change in y, change in x. Ooh, got to be tricky. It's getting more negative, so they are actually subtracting 15. Minus 15. Minus 15. And this is why we had that warm-up, because we want to be comfortable. Okay, this one is adding, each one is adding 1. So putting that change in y. Make sure if you forget that negative, it's going to be an oopsie. Okay, change in y was minus 15 over 1. That simplifies to negative 15. Okay, again, that's my n. That's my rate of change in the formula. Negative 15 x. Okay, so finding from a table, again, just finding that change every single time, pretty straightforward. Of course, you can do the same thing from a graph. Okay, so let's recall some information from last week. How can I get these points and find the x and the y? Okay, what I can do, I can just get the ordered pairs. This is 2, 6. This one is 3, 12. 2, 6, 3, 12. Okay, finding those changes. This is doing plus 12. Oh, no, maybe it's not. That's plus 6. This was plus 1. Okay, finding that change in y over the change in x. That's 6 over 1, which simplifies to 6. Bueno. Okay, so if you're rocking and rolling with that table, awesome. I want to show you another way, though, that you can see it on a graph. Okay, usually you can only see this on a graph. It's harder to see on a table, but this might be easier. Okay, so we already talked about how the multiplier, constant rate of change, is sort of just a fancy word for the multiplier. Okay, but we have another word that we can throw in there. It is also called the slope. Okay, because it's talking about like the incline of the line. Okay, the slope is talking about how much it's changing each step of the way. Okay, why? Because it shows the incline of line. Okay, so the way that you can find the rate of change, the way you can find the slope is the same thing, is we can look at the rise over the run. Why are we, you might be thinking like, why are we learning a different way? Well, it's just the same thing. Okay, the rise is talking about how much it goes up. Okay, and if we're looking at the change up, we're still looking at the change in y. Rise is still talking about the change in y. Run, oh, let me label this just so we are clear. This is the rise, and then the run is going this way. Okay, and if I'm going this way, going from one point to the other, this is on the x-axis. So finding the run is still finding the change in x. It's just maybe words that make more sense to you. Rise over run. Okay, no matter what, we'll still have the same thing. My rise, if I went from 6 to 12 on that y-axis, from 6 to 12, my rise was plus 6. Okay, my run, I went from this point to this point. I went from 2 to 3. My run was plus 1. Okay, so if I put those numbers in over here, rise was 6 up and over 1, which again equals to 6. If you'll notice, that is the same thing that we found here. The m is equal to 6. Okay, let's look at one more. Again, it's up to you if the table works or looking at rise over run. Okay, let's do the first way. Okay, let's do rise over 1 first. Again, rise is how much it's going up. You'll see in a few problems, if it's going down, it's a negative rise. If you're going up, it's a positive rise. If I'm going from 3 to 5, that is 5. Okay. Oh, no, it's not. Oopsie. Oopsie. Okay, that from 3 to 5, that rise was plus, oops, plus 2. My run going from this way to this way, my run was plus 1. So 2 over 1 simplifies down to 2. My slope, okay, remember this is the same thing as m, which is talking about the rate of change, is 2. Now maybe the table works better for you, finding the points and doing the table. Okay, the ordered pair for this one, 1, 3. This one is 2, 5. Okay, if I put that in my x, y, it doesn't matter which one you put first. 1, 3, 2, 5. I'm increasing by 2, increasing by 1. If I put the change in y over the change in x. Again, this is all the same thing, so it's just giving it different names. 2 over 1, which is equal to 2. Okay? Now, with these two, these are those two-step problems that I mentioned, where I have a multiplier and I have an adder. Okay? Let's look what I mean. Okay? If I look at this, okay, if I just look at those numbers, 2 to go to 6 would be times 3. If I tried to multiply the same 3, it doesn't give me 3 times 3 would be 9. Okay, so that's not looking like straight multiplicative. If I tried to add, 2 plus 4 gives me 6, 3 plus 4. So it's not additive or multiplicative. It's a combination of things. Okay, so the way that we're going to practice doing this tomorrow, again, y equals 6x. That was my multiplier. We need to figure out what we need to add. Y. This is like the parent function plus b. I found out that m is equal to 6. I now need to figure out what I need to add or subtract. So if I put in 2, y equals 6, I'm going to put in 2 and try and get 6. Okay? If I put in 2, I'm at 12 right now. To get an output of 6, to go from 12 to 6, I need to subtract 6. I need to subtract 6. Okay? So let's check that with if I put in 3. If I say 6 times 3, that's 18. And if I take away 6, like I said in this equation, that would give me 12. Okay? So again, just looking at it, it's not multiplicative, it's not additive, it's a combination of two. Okay, it's a two-step equation. And again, we'll practice this tomorrow. I'm just showing you if you took a look and you're like, wait, it's not multiplicative. It's not just 6x. You're correct. Okay, we have 2 steps that we need to do. You can try on this one. You will get y is equal to 2x because that's my multiplier, but I would still need to add 1 to get the correct outputs. And again, we'll practice that tomorrow. All right. Back page. Okay, so this is just re-emphasizing. Remember how we said the constant rate of change always forms a linear relationship? Okay, we talked about how it always makes a straight line because it's staying constant. The slope, the rate at which it's going, will always stay the same. If you ever see a graph and it's like changing, like, oh, this one made it more steep and then it got really flat, you would be able to see just visually that it is not a constant rate of change. It does not have a slope. Okay, it's a changing. If it is linear, that means it has a constant rate. So that line depicts a constant unchanging ratio, and that is called the slope of the function. Okay, it's just one slope. With linear graphs, we can use any 2 points. It does not matter if it's these two. It doesn't matter if it's this one and the last one. If you skip a few, you can use any 2 points, and you will always end up with the same rate of change. Okay, so again, slope is the change in y over the change in x. Okay, again, that change in y, that's talking about the vertical change. That's why we also call it the rise. The change in x, the horizontal change, is the run. Okay, this is what you'll hear when you grow up in like high school math and stuff like that. Maybe you have older siblings and you've heard rise over run or slope. Okay, so practice those next 2. Pause and play when you're ready. Okay, rise over run, or change in y over change in x, literally whatever works for you. Okay, I'm going to look here. I'm going to go with these first 2 points. Okay, I went from 3 to 9, so my rise was 9. My change in x, I went from 0 to 1, 1. My m, my slope, is equal to 9. Y equals 9x. Okay, again, I'm having you find it this way for a specific reason. Okay, so what about this one? I have 2 spaced out dots, and then I have this one. I had a few students ask if that changes anything, so let's look. Slope is change in y over change in x. The change in y, it went up from 0 to 120, and it changed in x from 0 to 2. Okay, that gives me 60. Now, what if I had these two closer points? Let's figure it out. Okay, let's see if it changes. Okay, from 120 to 80, that's plus 60. From this to this, that's only moving 1. So rise over run, 60 over 1. Hey, look, it's the same thing, okay? Because it's that straight line, it is going to have a constant rate of change. All right, just a little bit more. So if you're at home, this is on the resources, and if you're in person, you probably got a copy of this. So if you look at it, at the very top of the 7th grade star chart, they have this equation right here, which is what we've sort of been working on. Okay, the slope intercept form, this is the equation we've been using to write for lines. Y is our output, X is our input, and what we've been looking at today, again, is M, which is our rate of change, or more commonly known as our slope. Okay, the big thing is you need to understand that these two are the same. All right. Okay, so again, the formula for linear relationships is most commonly represented by y equals mx plus b. Mx plus b. This is exactly the same as y equals mx plus a. Again, it's just a different letter. It's talking about what you're adding. Don't get confused or anything like that. It's just something you need to practice, that m is the same thing as the slope. It is the same thing as the rate of change. They are synonyms. They are interchangeable. Okay, and lastly, we can put this into real world context. It's not just numbers on a graph. There's real world situations. Okay, let's read. The table shows the relationship between the number of seconds it takes to hear thunder after a lightning strike and the miles you are from the lightning. Graph the data and determine the slope. So the slope, as we know, the definition of the slope is finding the rise over run, or the change in y over the change in x. It says let's use these 2 points to help us find it. So that's going to be from these 2 points on the table or from these 2 points on the graph. Either way. Okay, the change in y from here to there, it's increasing by 10. This is increasing by 2. I need to put the change in y, 10 over the change in x, 2. Let's check and make sure that's the same over here. Again, this is the same as rise over run. It's rising 10 and running over 3 to 5 is 2. Same thing. This simplifies, of course, down to 5 over 1 or just 5. My slope, my rate of change is 5. So for every blank between a lightning flash and the sound of thunder, there is blank between you and the lightning strike. For every 5 seconds between a lightning flash and the sound of thunder, there is 1 mile between you and the strike of lightning. Okay, because if you think 10 over 2, 10 was talking about the change in seconds, and 2 was talking about the miles. Okay, so what you need to do, just practice. This gets better with practice. On this last little sheet, you are finding the rate of change, or the slope, whatever you want to call it. You are finding it for all situations. Okay, so we should see this work on each problem. Change in y over the change in x. What does that equal? Use any points, and it doesn't matter. Okay, please check on Canvas. Thank you.